Okay, let's unpack this. Almost overnight, it feels like, AI became this primary tool. Students, knowledge workers, everyone's using it to produce output.
Yeah, it's everywhere now.
But it creates this profound tension, right? Are we actually generating new knowledge, really learning, or are we just relying on, what was the term, borrowed competence?
Exactly, borrowed competence.
Yeah.
Does it just vanish the second you turn the tool off?
Yeah.
That's the core question.
We need to know if this, burst of accelerated output is leading to real, durable learning. Or is it masking some kind of long-term cognitive cost we haven't fully grasped yet?
Well, that tension is precisely why we need to move beyond just anecdotes and look at the actual data,
Hmm.
hard data.
Right.
And for this deep dive, we've got two really remarkable sources. At first glance, they seem to conflict, but I think they actually give us the complete picture.
Okay, what have we got?
So first, there's this massive multi-study project from researchers at Penn. They focused on tangible, measurable skill gains. Did the writing actually get better over time, objectively?
Got it. Measured improvement.
And then we have a neuroscience team at MIT. They used EEG caps, measuring brain waves in real time.
Ah, okay. To see what the brain is doing.
Precisely. What's happening inside when we use these large language models is fascinating stuff.
Okay, so our mission today seems pretty simple then. We're going to map those trade-offs, the proven pros from Penn and the scientifically measured cons from MIT.
And deliver a practical playbook, something you can use immediately.
Yeah, the goal is to help you use AI like a coach, something that amplifies your skills, not just a crutch that lets them get soft.
Maximum benefit, minimum cognitive debt. That's the aim.
So the core idea AI really challenges is that old notion that struggle builds skill. Many of us learn that if it feels too easy, it must be superficial.
Right, the no pain, no gain of learning.
But maybe that struggle wasn't always teaching skill. Maybe sometimes it was just inefficient trial and error.
It's possible. Sometimes getting the perfect example or seeing the clearest structure can just click things into place. It could compress months of fumbling into one breakthrough moment.
So we have to be open to the idea that, yeah, genuine learning can actually be efficient sometimes.
In the Penn study, that's probably the strongest evidence for that efficiency argument. They tracked objective, measurable writing gains over time. Quality, clarity, structure. The works.
And they found
Clear, sustained improvement, even a full day later. And it held up across different kinds of writing tasks.
Wait, how sustained, when you talk about academic gains, context matters. How big was this improvement, really?
Oh, substantial. In one key comparison, they measured an effect size of D0.41. Now, for anyone not deep in stats,
Yeah, translate for us.
you can think of that as a solid, moderate to strong improvement. It wasn't just a fleeting boost. The skill gain was stable. You could easily see it in the participants' later work when they weren't using the AI. The procedural knowledge, the how to write well, that seemed to be sticking.
Okay, that sounds like a pretty decisive win for AI as a coach then. Skill sticks, effort goes down. So why are we still worried? What's the catch?
Because here's the really surprising bit from the Penn research. Get this. Participants who simply viewed a high-quality AI-generated example, just looked at it. They produced comparable writing improvements to the people who actively practiced with the AI, asking it to rewrite their stuff over and over.
Wow, really? So just seeing a good example worked almost as well as active practice with the tool.
Yeah. It kind of flips the script on traditional learning, doesn't it?
Yeah.
It suggests the main mechanism isn't just brute force effort, it's the quality of the example, the clarity of the feedback.
So learning by example, like having a great coach demonstrate perfect form just before you try.
Exactly that. Perfect analogy.
And the efficiency part was key too, right?
Absolutely paramount. The data showed people using AI used less time, fewer keystrokes. We quantified that reduction, D equals 0.44, and they reported less effort.
Less effort, but still better output and learning.
Still superior. It's powerful proof that efficiency and genuine improvement can go hand in hand. They aren't mutually exclusive.
Okay, that's compelling.
It certainly is.
Yeah.
But, and this is a big but, here's where it shifts entirely. We have to bring in the hidden cost that MIT measured.
Right, the brain scans.
Yeah. If the output quality was better and the effort felt lower, what price was the brain paying in that moment?
And the price it was.
Profound cognitive offloading. That's the term they use. The MIT team found that when participants leaned on the LLM to produce, say, an essay or an argument, their brain activity narrowed dramatically.
Cool.
Using those EEG caps, they saw which neural regions were talking to each other.
Mm.
When writing unaided, without AI, the connectivity was broad, strong, lighting up networks we associate with creative integration,
Mm.
critical thinking, working memory.
The whole orchestra playing together.
Exactly. But with the LLM active, that rich, complex connectivity,
Mm.
it shrank down to just a few local regions.
Mm.
It's kind of like, when you rely on GPS constantly while driving, you navigate okay, but you're not building that internal mental map of the city.
Right. You don't really learn the route.
Your brain essentially said, okay, I don't need to fire up the full creative engine here. I just need to supervise the output coming from this external thing.
So it wasn't bringing in the big guns, the holistic creative processing regions. It was basically just acting as the quality assurance department, checking the input.
That's a great way to put it, just supervising. And I imagine that had immediate consequences for memory.
Oh, immediate consequences, definitely. Participants in the LLM condition, they recalled significantly less from the paragraphs they had just written minutes later.
Wow, minutes later, yeah.
Yeah.
They also reported a lower sense of ownership over the text. It felt less like theirs.
So the specific step-by-step reasoning just vanished because the brain never fully encoded the content in the first place.
That's the definition of cognitive offloading in action. Precisely.
Okay, so now we have the paradox, right? Penn sees these procedural gains a day later. The ability to write better seems to improve.
Right.
But MIT sees these immediate recall costs and reduced brain activity, losing the specific content and maybe dulling the thinking process itself.
Yep. Yeah, that's the core tension.
So how do we reconcile these two? Regarding memory, critical thinking, what does this actually mean for someone sitting down to use AI right now?
Well, I think we have to realize we're tracking two different kinds of memory systems, really. MIT was focused on that immediate, specific content encoding. Can you quote or outline the argument you just produced?
Okay.
And that's where using AI absolutely created a deficit, especially if the task needed unaided step-by-step reasoning.
Yeah.
It's a definite red flag if you're studying for an exam based on specific recall.
Makes sense. But the Penn team, testing performance a whole day later, still saw that functional improvement in writing quality. The skills seemed to stick.
And that's the key operational difference. It looks like AI is tremendously effective at helping you internalize procedural knowledge.
The how-to.
Exactly. It teaches structure, clarity, revision heuristics, the how of writing better. You learn the abstract principles of good communication, the patterns, even if you don't remember every single sentence the model generated to get you there.
And that leads us straight back to the critical thinking deficit MIT measured. That neurological shift wasn't random, right? It moved away from those distributed generative networks.
The parts of the brain that create and synthesize new ideas.
Yes.
And shifted toward.
And narrower supervisory patterns. Think of it this way. Your brain stopped being the architect designing the building and instead became the inspector, checking the blueprints someone else drew up.
Okay, I see. Less creation, more oversight.
And this neurological mechanism, it's precisely what critics were worried about. That repeated passive use dulls the impulse to really interrogate ideas, demands less original synthesis. That is the biological basis for what people call cognitive debt AI.
So it feels like the core insight here is sequencing. It's about when and how you use the tool. Yep.
If you just passively receive the output, you lose the content and you reduce that critical engagement. But if you use AI smartly, maybe to model strong examples like Penn showed,
then you can internalize those abstract principles. How to order evidence effectively, how to cut the fluff.
Right, so the message isn't ban it. It's more like choreograph the engagement, figure out the right dance steps.
Exactly. We need a clear choreography for this dance between our own cognition and this automated assistance.
Yeah, this isn't about setting up a bunch of strict new rules nobody follows. It's about sequencing work. So your brain fires first, builds the scaffolding, then the tool comes in for refinement.
And that framework aligns perfectly with both the Penn and the MIT findings. It ensures AI acts as a true coach, not that cognitive crutch.
Okay, let's detail this playbook. What are the steps?
Okay, there are 5 key steps.
Step 1.
The cold start practice first, AI second. Always.
Meaning
you must start. Every assignment could be a big project, could be just an email with a short, unaided attempt. No AI.
even just for a few minutes.
Even just 10 minutes of free writing, a rough outline, scribbling some bullet points, anything. The MIT crossover design was really clear on this. When your brain fires first, you establish those initial neural pathways.
So you lay down the initial track.
Exactly. Then, the subsequent pass with AI has a stronger base for evaluation and editing. It helps prevent that immediate cognitive offloading we talked about. Don't let the AI do the first messy thinking. Make your brain do it.
Okay, step one, brain first. Got it. Step two.
Use AI for examples, not final products. This leans right into the Penn data.
Right, the power of seeing a good model.
So instead of asking the AI to rewrite your paragraph until it's perfect, ask it to produce a model answer to your prompt, a separate example.
Okay.
Then spend your cognitive energy critiquing that model. Why did it order the evidence that way? Where did it choose to put the main point? You're adapting the structural patterns, the good ideas, back into your own work.
So you're learning from its structure, not just pasting its words.
Precisely. It's the safest way to gain skill without eroding your authorship or feeling that lack of ownership.
Makes sense. Okay, step three.
Engage. Critically argue with the model. This directly tackles that supervisory pattern issue MIT found.
Don't just accept the output.
Absolutely not. When the AI gives you something, don't treat it like gospel. Treat it like a draft from a talented but maybe slightly lazy intern.
Oh, okay.
Force yourself into an active mindset. Ask it to explain its reasoning. Challenge its unsupported claims. Ask for opposing viewpoints.
So questions like, is that actually true? Or what's the evidence for that?
Exactly. Those kinds of questions force your brain back into a generative interrogative role rather than just passively supervising. You're back in the driver's seat.
Okay, step four. You called it instrumenting the effort.
Yeah, this is about keeping the task slightly hard, making sure there's still some cognitive friction so you're deeply engaged.
How do you do that?
You design your prompts to demand more than just simple retrieval. Ask for justification, transformation, or comparison. Instead of just summarize this article, summarize this, but reframe it for a skeptical audience of parents.
Adding a constraint or a perspective shift.
Or summarize this using only metaphors related to architecture, something that forces your brain to restructure the information actively, not just passively consume it. Learning stays active, even if the tool reduces the typing.
Clever. Okay, and the final step, step five.
Close the loop without AI. Teach it back. This is crucial.
For memory consolidation.
Absolutely essential for consolidating memory. End your study session, your practice block, whatever, by summarizing the key ideas entirely without the tool. Turn it off.
How? Like out loud?
Could be verbalizing it, yeah. Or write down a brief, maybe 90-second explanation of what you really learned. That little ritual forces recall, consolidates the memory.
And it gives you a clean read on what actually stuck.
Exactly. It directly counteracts that short-term recall deficit MIT observed. If you can teach it back, even just to yourself, you probably own the knowledge.
That whole sequence, practice, first, refine, teach back, seems like it applies way beyond just students, right? Workplaces, teams.
Totally. For teams, it means maybe asking for an unaided straw man draft of a proposal before everyone jumps in with AI assistance.
Yeah, get the raw thinking out first.
Or using peer teachbacks in stand-up meetings to consolidate project knowledge. Make sure the whole team truly internalize the strategy, not just, supervise the AI generating the project plan.
We need ways to measure the impact on skills directly, make sure we're actually compounding competence, not just automating output.
And if we connect this back to educators and parents, the mandate seems pretty clear. Sequence the tasks, always have a generation stage first, then a comparison or refinement stage.
Require that first draft, that outline, without tools. Then, okay, now you can use AI for feedback or to see those high-quality examples. But that means assessment has to change too, doesn't it? We can't just grade the final polished thing anymore.
No way. You absolutely have to grade the process. Collect the unaided first draft. Collect the AI-assisted revision. And critically, collect a brief rationale from the student. Why did you make those changes? Why did you accept that AI suggestion, but not that one?
So you make them accountable for their cognitive choices. That flips the incentive structure towards honest practice.
It does. And then, to assess genuine retention, to spot that reliance gap MIT found.
How should we test?
You need to assess retention without support. Use things like spot quizzes, brief oral defenses, maybe short closed book whiteboarding sessions, low-stakes stuff.
So you can see if they really learned it or if the tool was doing all the heavy lifting.
Precisely. If they relied too heavily on the crutch, these no AI tasks immediately show the gaps. If they used AI well, like a coach, these assessments will show genuine growth. The goal shifts, right? It becomes about teaching meta skills, problem decomposition, evaluation, explanation, not just teaching how to write the perfect prompt.
We've talked a lot about the cognitive cost, the sort of mental debt. But there's a literal material cost too, isn't there? That probably belongs in any full review.
We definitely should acknowledge the energy cost. It's often hidden, but it's relevant.
How significant is it?
Well, research appended to the MIT papers highlighted that a typical LLM query consumes roughly 10 times the energy of a traditional Google search.
10 times. Wow.
Yeah. That fact alone really reinforces the need to be purposeful, intentional with AI exposure. Not just constant automatic use for everything. If it costs 10 times the energy, it really ought to deliver significantly more value in learning or productivity.
That puts it in perspective.
So, look, we don't have to pick a side in some false war between the tool and the mind. The research, taken together, is pretty clear.
What's the bottom line?
When AI is used with intention, thoughtfully, focusing on quality examples like in the Penn study, it's an extraordinary accelerant for learning procedural skills. It's a great coach. But when it's used passively, just for shallow supervision, like the MIT brain scans showed, it absolutely acts as a crutch. It leads to weaker memory encoding, lower ownership, less cognitive engagement. Both things are true. It just depends entirely on how you sequence your interaction with it.
So the solution for every learner, every professional listening, is agency and sequence. You have to take control.
Design your practice. Make your brain fire first. Generate that initial cognitive scaffolding. Then let the tools come in to refine and accelerate.
That intentional approach lets you learn faster and deeper, not skip the learning entirely. Makes sense.
It's about being deliberate.
Okay, so here's a final thought then, building on this playbook. If you, listening right now, adopt this 5-step sequence for your next complex project, start with that rough, unaided draft, then move to comparison and refinement.
Hmm.
What specific skill, maybe one you thought was already automated by AI, will you realize you still need to consciously practice? And maybe more importantly, how will you measure that improvement for yourself next time?
That's a great question to ponder.
Something to consider as you design your own learning path going forward.